So we're following on from the previous video that looked at using trigonometry to find missing sides in right angle triangles. This video we're looking at trigonometry to find missing angles in right angle triangles. Okay, so previously, on the previous video, if you missed that, you can give that a watch. We looked at finding missing sides, like you can see here. These are all missing sides. But this video we're looking at finding missing angles. Okay, so, but it works in the same sort of way. In the exact same way, right? You get your triangle, you label it, you find your formula, and you go from there. So let's just begin. Example 1. So we'll go through 2 examples, and you can try 3 yourself, and then that should be good. Okay, so example 1 is use trigonometry to find the missing angle theta. Again, that just means angle theta. But the same principle as last time, right? You label your triangle with regards to the angle given to you. So the side opposite the angle, okay, always we call the opposite side, O. Your longer side opposite the right angle is called your hypotenuse, so that is H, okay? And then the missing side is the adjacent side, but because there is no information there, leave it blank. Otherwise you get confused on which one to pick, which formula to pick. So now your triangle is labelled. Right, we look over to our SOH CAH TOA. Which one has got both O and H in it? Well, it's the first one. Right, so we've got both O and H, so we're using this formula here. So the same things before, right? You label your triangle and you choose your formula. But now, right, it's slightly different. We're trying to find the missing angle theta. Well, the theta bit belongs to this bit here, sine of the angle theta. So let's go and write that down. So we've got sine of the angle theta. Put your finger over it to find out the formula that you need to use. And it's going to be O, opposite, divided by hypotenuse. So sine of the angle theta is O divided by the hypotenuse. And now you've got your formula chosen, okay, and rearranged for you already using the triangle. You just substitute in your values. So we've got sine of the angle. Well, the angle here, it is just the same thing, theta. So sine theta is equal to O. O is 3. So 3 divided by H, and H is equal to 6. Okay, maybe you're thinking here, well, I've got sine of the angle theta. Maybe I could go and divide through both sides by sine theta. You can't do that, right? Sine theta does not work in the same way as like 3x is equal to 12. You cannot go and divide through both sides by sine like you can with this. It doesn't work like that. To get the missing thing, theta, that's what we're trying to find on its own here, we do something a bit different called sine inversing. So we write this, the missing angle theta is equal to get rid of that sine there, we've got to sine inverse both sides. So we sine inverse, which gets rid of that sine, and then on the right hand side over here, we get sine inverse, and then the angle, 3 over 6, or a half, so 3 over 6. So the different thing with angles, right, is when you get to this bit here, to get the angle on its own, you've got to do and this bit is called the inverse, so that -1, okay, we call the inverse of sine, okay? And to get this on your calculator, right, if you've got a Casio, which is what I've got now, you press shift, or it might say second function, but it's going to be in the top left, roughly, of your calculator. So you press shift, you then press sine, and you should see that little -1 bit. And then you got your bracket, and you write in 3 over 6, okay, which is exactly 30 degrees, okay? And that is not usually the case. Usually you get a decimal, okay? You'll see on the previous video, right, because we've got, and this is an exact value, right, it's exactly 30 with no decimal, that is a special trig value, which you'll see later on. But anyway, right, the missing angle here is equal to 30 degrees, right, so this angle here, theta, is equal to 30. So it works in the same way as before, right, you get your triangle, you label it, you then choose your formula, and then you put in your values. But this time, to get the missing angle, you've got to do this thing called sine inversing. And it's the same with cos and tan. You do the cos inverse and the tan inverse. Okay, right, example 2. Let's have a look at it. Same things before, though. So use trigonometry to find missing angle x. Okay, so I want to find x, which is here. Again, begin by labeling up your triangle. So the side opposite the angle is the opposite side, but there's nothing there, so leave it blank. Okay, leave the side, but there's nothing there, blank. You've then got the longer side opposite the right angles, which is the hypotenuse, and then the remaining side next to, adjacent to both the angles, is your adjacent side. So there we go, I've got my triangle labelled up. I've got A and H. Well, it can't be SOH because there's no A, and it's going to be CAH because I've got A and I've got H. And again, right, I'm trying to find the missing angle X. So the angle part is this bit here, cos of the angle theta. So I can go and write that down. So cos of the angle theta, and go and put your finger over it to get the formula that you want for it. It's going to be equal to the adjacent side divided by hypotenuse. So that's equal to A over the hypotenuse. So label your triangle formula, and then you substitute in. So I've got cos of the angle. Well, the angle, I've called it x here. That's what I'm trying to find. So I can go and write cos of the angle x is equal to my adjacent side. Adjacent side is 3. So 3 over the hypotenuse. Hypotenuse is 8. So 8, there we go. To go and find x now, I've got to go and cos inverse both sides. So I write it as x being equal to cos inverse 1, 3 over 8. So 3 over 8. And then you put it into your calculator. This one will not be an exact value, it will be a decimal. So cos inverse 3 over 8, and you should get 67 or 68 degrees to the nearest degree. So to the nearest degree. Okay, if you didn't get that, your calculator might be in the wrong mode. Okay, it might be in something called radians mode or even gradians mode. To try and reset your calculator if you did not get that answer. Okay, so if you type this in, cos inverse 3 over 8, and you get something different, your calculator is in the wrong mode. So you've got to try and reset it somehow. Okay, but that's your answer, 68 degrees on example 2. So now, right, you can go and try these 3 yourself. If you get stuck, you can always, of course, fast forward and go through it with me at any point. But give those a go, and you can see the answers at the end if you need to. So all these questions here are about finding missing angles. Let's go and do that. The first one, it's always the same thing. Angle, label it up. So opposite side is O. This side here is my hypotenuse, but I don't need it. There's nothing there. So this is my adjacent next to my 2 angles. So I've got O and A, which means I'm using TOA because I've got O and A, and this has got O and A. So I'm using this formula on this one. I'm trying to find the missing angle X. So that's going to be the tan theta part of the angle. So tan of the angle theta is equal to, put your finger over it, because that's what you're trying to find, and you can see it's O divided by A. So we've got O divided by A, and then it's just a case of substitution. So theta is equal to X, the thing I'm trying to find, the missing angle. So tan of the angle X is equal to, my opposite side, opposite is 9, so 9 over my adjacent side, which is 20. I go and put it in. To get x on its own, I've got to get rid of the tan here. I do that by doing the tan inverse of both sides, and then if I tan inverse 9 over 20, right, I will get my answer. So this time I've got tan. I'm using tan. I tan inverse it and put 9 over 20, and you should get 24.2 degrees. 24.2 degrees to 1 decimal place. Okay, of course your rounding here might be different, but look, if you've got 24.2, 24.22, that's absolutely fine. So there is my first answer. Okay, question 2. Same start as always, right? You've got your triangle, you label it with regards to the angle. So I've been given my opposite side. Let's use a different colour pen. Let's use green, keep it consistent. So I've got my opposite side. I've been given the longer side, opposite the right angle, so my hypotenuse. So I've been given O and H, which means I'm using the first one this time, SOH. Okay, because I've got O and H, I've got O and H in that formula. I'm trying to find the angle, which is the sine theta part. So you put your finger over it and you say that sine of the angle theta is equal to opposite divided by hypotenuse. So O over H, and then you just substitute. So theta is X, so sine of the angle X is equal to my opposite side, O is 4, so 4 over hypotenuse, which is 15. To find X, I've got to sine inverse both sides. If I do that, we write it as X being equal to sine of the inverse 4 over 15, which is equal to sine inverse 4 over 15, which is 15.5 degrees, and that is to 1 decimal place again. Okay, so that's my answer with that one. Let's go and keep it in the same colour. Highlighter yellow. There we go. Brilliant. Okay, last one. Last but not least, we've got a triangle that's been rotated, but which makes it maybe a bit tricky to label up, but it's the same idea going on again. Right, I've got my right angle triangle, I've got my angle, the side opposite the angle as my opposite side, but there's nothing there, so leave it blank. I've got my longer side opposite the right angle, which is going to be my hypotenuse, which must mean that that is the adjacent to both of the angles in the triangle. So this time, right, I've been given the A and the H side, which is going to be not a SOH, it's going to be CAH. I've got A, I've got H, A and H. And then I choose my formula. I'm trying to find the angle, which is the cos of the angle part. So put my finger over this part and say that cos of the angle theta is equal to my adjacent side divided by hypotenuse, so A over H, and then substitute. So the angle I'm trying to find is just called x here, so I say cos of the angle x is equal to adjacent, A is 11, so 11 over hypotenuse, which is 15. To find x, I go and cos inverse both sides, so x is cos inverse 1 of 11 over 15, and then type that into my calculator to get my final answer. 11 over 15, which is equal to 42.8 degrees. So 42.8 degrees, and there we go. Okay, that is my final answer. So hopefully that was useful, and hopefully you're realizing, right, trigonometry, it really isn't that bad. It's just label your triangle properly, you then choose your formula, and then you substitute, and then that is it. It's just with angles, you've got this extra step, which is to inverse either sine, cos, or tan. Okay, so tan on the first one, sine on the second one, cos on the third one, depending on which trig ratio that you're using. Okay, thank you.